All right, so you've set up your read replicas, your application is flying. But you've got a new problem, a big one. Your main database, the one handling all the writes, is starting to choke. You're just getting too much data, too many new users, and that single server just can't keep up anymore. So, what do you do? Well, today we're going to dive into the ultimate solution for massive scale, sharding.
And to really get why this is such a big deal, let's just start with a number. 2 billion. That is roughly how many active users a platform like Instagram has to deal with. Now, how on earth do you manage that much data, all those people, on a single database? The simple answer is you don't. You can't. It's impossible. Eventually, any single machine is going to hit a hard wall.
And this is what that wall looks like. We call it the breaking point. Suddenly, queries that used to be instantaneous are just grinding to a halt. Your service disk space, completely maxed out. You don't have enough RAM to even hold the indexes in memory, which just makes everything even slower. And maybe the scariest part of all, your entire application now hinges on this one single overloaded machine. If it goes down, everything goes down.
This is where we need a hero, and that hero is sharding. It's a really powerful strategy that's designed to solve this exact crisis by, well, fundamentally changing how we think about storing our data.
So, what is it really? Sharding is the practice of horizontally partitioning your database. Now, that sounds super fancy, but it's actually a pretty simple idea. All it means is we're taking all the rows in our table, all our users, all our products, and we're splitting them up across a bunch of smaller, totally independent databases. We call these shards. Each shard just holds a piece of the whole puzzle.
You know, the best way to think about it is with a library analogy. Imagine a library with 1 million books. Without sharding, it's just one giant, chaotic room. Trying to find any specific book is a total nightmare. But with sharding, it's like we've organized that library into multiple smaller rooms. You know, one room for books A through E, another for F through J, and so on. It's the same number of books, but now everything is organized. It's manageable, and it's way, way easier to find what you're looking for. And we can see exactly how a company like Instagram puts this into practice. Okay, so they start with their 2 billion users. They decide to shard, or split up, their data based on each user's ID. They could, for example, split it into 4 shards, with each one holding about 500 million users. And what's the result? Well, instead of a query having to search through a single table with 2 billion rows, now it only has to search a table with 500 million. It's just so much faster.
Okay, so we get what sharding is, but how do you actually do it? Turns out there's not just one way. There are several core strategies. So let's explore the 4 most common ways to shard your data.
First up, we've got key-based or hash-based sharding. This is a really common approach. It's pretty straightforward. You just pick a column in your data to be your shard key. Something unique, like a user ID, works great. Then you run that ID through a hash function, which just spits out a number. And that resulting number tells you exactly which shard to store that user's data on. It's a purely mathematical way to spread the data around. Now, here's the deal with this method, the core trade-off. The huge, huge advantage of hash-based sharding is that it spreads your data out very, very evenly. This prevents any one shard from getting overloaded. But, and this is a big but, the major drawback is that you can no longer do range queries. You can't just ask for all users with IDs between 1,000 and 2,000 because that hash function has scattered them randomly across all the different shards.
The second method is range-based sharding, and this one is way more intuitive. Instead of using a complicated hash function, you just divide your data up into continuous chunks. So, for example, user IDs 1 through 1 million go on shard 1, user IDs 1 million and 1 through 2 million go on shard 2, and so on. You can also do this with things like dates, which is awesome for time series data.
And the trade-off here is the exact opposite of hash-based sharding. It is fantastic for those range queries we just talked about. But its key challenge is uneven distribution. Just think about it for a second. If all your new users are signing up right now, all of that new data, all those writes, are hammering the very last shard. This creates what we call a hotspot, while all the older shards are just sitting there mostly idle. Not great.
Okay, our third strategy is directory-based sharding. This one is all about flexibility. The idea is you maintain a central lookup table. It's basically a map. Before your application goes to get some data, it first asks this central directory, hey, where can I find the data for user 123? And the directory then points the application to exactly the right shard. The power here is that you get incredible flexibility.
You can move data between shards, and all you have to do is update the directory. But, and here's the crucial point, that directory is now a single point of failure. If your lookup table goes down, your entire system grinds to a halt because nobody knows where to find anything.
And finally, we have geo-based sharding. This is pretty much essential for any global application. It's simple. You just partition your data based on where your user is physically located. So users in North America, their data is stored on servers in North America. Users in Europe, their data is stored in Europe. You get the idea.
The benefits here are massive. For one, it gives users incredibly low latency because the data is physically close to them. It also makes it a whole lot easier to comply with regional data privacy laws like GDPR. The challenge? Well, any query that needs to span across multiple regions, like a global search for a username, suddenly becomes very slow and very, very expensive to run.
So, we've seen just how powerful sharding can be. It seems like the perfect solution to all our scaling problems, right? But, like with any major architectural decision, there's no free lunch. It comes with some really significant trade-offs. It's all about what you gain versus what it's going to cost you.
And this slide really sums it up perfectly. On the one hand, the win column looks amazing. You get almost infinite scalability, way faster queries, and higher availability, because if one shard fails, it doesn't take down your whole system. But the cost column is steep. Your system becomes extremely complex. Trying to join data across different shards is a developer's nightmare. And things like adding a new shard and rebalancing the data, well, that's just a massive operational headache.
And you know, maybe the hardest technical problem of them all is trying to do atomic transactions across different shards. Imagine you're transferring money from a user on shard 1 to another user on shard 2. You need both the debit from one account and the credit to the other account to succeed together, or you need them both to fail together. Guaranteeing that kind of consistency across two separate, independent databases, that is one of the most complex challenges in all of distributed systems.
So, given all of this complexity, it leads us to what is probably the most important question you and your team will ever ask about this topic. When should you actually do it? When do you pull the trigger on sharding? And the answer, almost all of the time, is not yet. Sharding too early is a classic engineering mistake. It immediately injects a massive amount of complexity into your entire system. It makes simple development tasks way harder, and trying to test things on your local machine almost impossible. The honest truth is, most applications will never ever reach a scale where sharding is actually necessary.
So before you even start dreaming about sharding, please make sure you've exhausted all the simpler options first. Have you set up read replicas? Are your database indexes fully optimized? Have you tuned all your slow queries? Do you have a really robust caching layer in place? And have you considered just buying a bigger server? That's called vertical scaling, and trust me, it can take you a very, very long way.
And that really brings us to the core takeaway here. Sharding is an incredibly powerful tool for hitting massive scale, but it is also a weapon of immense complexity. The goal is never to build the most complex system you can think of. The goal is to build an architecture that is as simple as it can possibly be today, while still giving you a clear path to scale when and only when you truly need it.